Alright, in this lesson we are solving cube root equations. It's fairly straightforward, but you have to work out quite a bit with these problems because we have to check our answers as well. Step one, we move stuff around, so we want to get the cube root part by itself on one side of the equal sign. And in step two, we would cube both sides completely. Step three, we get the variable by itself. Step four, we check our answers. So we always like to check our answers. And basically, if you remember, do reverse PEMDAS to the inverse operations to release the items or get rid of the cube roots or cubes or squares or whatever else it is. So I'll take you through these, and I think you'll see they're fairly simple overall. This first one, okay, cube root of 11x minus 58 equals negative 9. So in this case, we don't have to move anything. All we need to do is cube both sides. So when we do that on the left hand side, the cube root goes away. We get 11x minus 58. Negative 9 cubed, when we do that, we get negative 729. That means negative 9 times negative 9 times negative 9, in case you're wondering. So now we're just going to solve for x. So 11x, and we need to add 58 to both sides. When we add 58 to negative 729, we end up with negative 671. And then we're just dividing by 11. And it's probably not in your head, but negative 671 divided by 11 is negative 61. Now, we need to check our answers. We always want to check to make sure it actually works out. So when we plug in negative 61, we plug that into the cube root of 11 times negative 61 minus 58, and then we ask ourselves, does that equal negative 9? So we know 11 times negative 61 is negative 671, and we subtract 58. Does it equal negative 9? So this is the cube root of negative 729. Does that equal negative 9? Yes, it does. Negative 9 equals negative 9. So x equals negative 61. Works out. And by taking the cube root, that means basically negative 729 is negative 9 times negative 9 times negative 9. So that's asking what number multiplied by itself 3 times would give you that. So it's negative 9. That's what you take out. Okay. Number 2. All right, once again, we can just immediately cube both sides. And you notice I've thrown in negative numbers because I know you love them so much, but we need work on those. So this cube root goes away. So we have 3x cubed plus 67 equals negative 5 cubed is negative 125. Remember, a negative number that's cubed stays negative. All right, so we need to subtract 67 from both sides. So I get 3x cubed equals negative 192. I need to divide by 3. So I have x cubed equals negative 64. If you have something cubed, how do you get rid of something cubed? You take the cube root. When I take the cube root, I'm left with x equals, and the cube root of negative 64 is negative 4, because negative 4 times negative 4 times negative 4 is negative 64. So now we want to check our answers. So we plug it back in. Cube root of 3 times, so in place of x we put negative 4 cubed plus 67. Does that equal negative 5? We'll find out. So we know that negative 4 cubed is negative 64. So this is 3 times negative 64 plus 67. Does it equal negative 5? We know 3 times negative 64 from up here is negative 192 plus 67. Does it equal negative 5? We're getting close. Negative 192 plus 67, that is negative 125. Does it equal negative 5? Well, cube root of negative 125 is negative 5 because negative 5 times negative 5 times negative 5 equals negative 125. So it checks out. So x is equal to negative 4. And we move on to our last one, number 3, this one. So at first glance, this one looks like it should be easy, but we're not sure what to do because we have cube roots on both sides, but then we have this 2. How do we get rid of it? Well, we can't really get rid of it. But what I propose is, because we have cube roots on both sides, we just cube everything. Cube everything. So I have 2 cubed times x minus 4. And then I have x minus 2 squared left over. So 2 cubed, I can figure that out. That's 8. 2 times 2 times 2. So that's 8 times x minus 4. And x minus 2 times x minus 2, well, if I distribute, that's x minus, or if I multiply it out, that's x minus 2 times x minus 2. Using FOIL method, I get x squared minus 2x minus 2x plus 4. So that simplifies. We have 8x now over minus 32 equals x squared minus 4x plus 4. Well, this is like problems we've done all year, basically since November, where it's a quadratic. We want to get everything on one side instead of equal to 0. So we're going to subtract 8x and add 32. So we have 0 equals x squared. So negative 4x minus 8x is minus 12x. Negative 32, or positive 32 plus 4 is plus 36. So if you look at that, using the A times C method, what two numbers multiply to be 36 and add up to negative 12? Well, we're left with x minus 6 times x minus 6. We set those all equal to 0. When x minus 6 equals 0, we know that x is equal to 6. So let's check x. Does x equal 6? Well, let's plug it in. So we have 2, I'm not going to use yellow, that doesn't work, that doesn't show very good. We have 2 times the cube root of 6 minus 4. Does that equal the cube root of 6 minus 2 squared? Well, on this side, all we can do is make it 2 times the cube root of 2 on the left-hand side. On the right-hand side, we have the cube root of 4 squared. 4 squared is 16. So left-hand side stays the same. Right-hand side becomes cube root of 16. Can I break down 16 into two numbers? Is there a perfect cube inside of it? Well, if I remember correctly, 8 is a perfect cube. So I'm going to take that out, and then I have left over 2, because 8 times 2 is 16. So the cube root of 8 is 2, and I have left over the cube root of 2. This left-hand side has not changed, so they are equal. So yes, x equals 6. So 3 problems there. So hopefully you understand solving cube root equations. We've solved every other type of equation we've had, quadratics, and inside these cube root solving you see that we had to do some solving for cubic functions as well. So it kind of combined, especially on number 2. So hopefully that is helpful in explaining how to solve cube root equations.